Why? 2024, Lay's parent company PepsiCo ran a survey. They asked a simple question. What are potato chips made of? 42% of people could not answer correctly. 42% of the people who buy and eat this product every day did not know it was made from potatoes. Lay's response was not to educate. They printed "made with real potatoes" on the bag and turned a public ignorance problem into a marketing campaign. But that bag has another secret inside it. Sometimes, buried among the golden chips, you will find a bright green one. It is not a flavor. It is not a defect. It is a tracking device placed inside the fryer on purpose. If you have ever found a green chip in a bag of Lay's and wondered what was wrong with it, nothing was wrong with it. That chip was watching the production line. We will explain exactly how and why by the end of this video. Every product has a secret. We go inside the factory to find it. The Lay's potato chip operation is not a kitchen. It is an industrial system that processes over 750 tons of raw potatoes every single day at a single European facility. PepsiCo is now one of the largest potato buyers on Earth, sourcing over 240,000 tons annually. The global potato chip market is estimated at over $20 billion, and Lay's alone generates over $4 billion in annual sales. The Walker's factory in Leicester, England, is one of the most automated snack production facilities ever built. It runs multiple production lines around the clock, integrating robotic packaging cells with carbon fiber arms designed to reduce inertia and increase speed. This is not a snack factory. This is a weapons-grade manufacturing plant that happens to produce potato chips. And the story of how we got here starts with one angry customer. In 1853, at Moon's Lake House in Saratoga Springs, New York, a diner sent his plate of fried potatoes back to the kitchen. Too thick, he said. The chef, a man named George Crumb, decided to teach this customer a lesson. He sliced the potatoes paper thin, fried them until they were brittle, and sent them out as a joke. The diner loved them. Saratoga chips became a restaurant sensation. But for the next 70 years, potato chips were made by hand in small batches and sold locally in bulk barrels. It was not until the 1920s that sealed packaging allowed wider distribution. Then, in the 1930s, a salesman named Herman Lay built a direct store delivery route system across the American South, going door to door to individual shops. That route system became so efficient that it eventually formed the backbone of a national distribution network. Frito and Lay merged in 1961. PepsiCo acquired the combined company in 1965. And in 1958, Lay's introduced its first flavored chip, barbecue, beginning the flavor arms race that now produces over 200 varieties worldwide. Step 1. Receiving and intake. A single truck delivers 20 to 25 tons of raw potatoes. The entire trailer is lifted onto a hydraulic platform and tilted to a 30-degree angle. Thousands of potatoes cascade onto the receiving conveyor. Before they move any further, quality control pulls random samples for starch content testing. A hydrometer submersion test measures the exact ratio of starch to water in the batch. That data is transmitted directly to the fryer control system, which adjusts cooking times for that specific truckload. This is not guesswork. The factory calibrates its fryers before the potatoes even enter the building. Screen systems remove stones and soil. Destoners separate rock from tuber, and a single mistake at this stage can cascade through the entire plant. In 2020, a wrong film roll at a Frito-Lay plant in Vancouver, Washington triggered a Class 1 allergen recall because the packaging declared the wrong flavor. One roll of plastic film, a full product recall. Step 2. Washing and peeling. The potatoes pass through high-flow rotary drum washers, then into abrasive peelers lined with coarse material. The tumbling action strips the skin while pressurized water jets wash the peels away. 6 industrial peelers at a major facility can process over 4 million potatoes per day. But here is where the factory gets smarter than most people realize. PepsiCo replaced physical weighing elements that cost $300,000 per production line with a machine learning computer vision system. Cameras now measure peel percentage in real time, and an algorithm controls the peeler set points dynamically. The machine decides how hard to peel each batch. No human operator makes that call anymore. After peeling, another camera system scans each potato for rot or defects. If something is wrong, a targeted puff of compressed air ejects the potato from the line mid-flight. Then, an automated size sorter separates the crop. Only standard-sized potatoes continue. Oversized ones are halved by blades before rejoining the line. If you are still watching this, You are exactly the kind of person this channel is built for. People who want to know what's really happening inside the products they use every day. Hit subscribe, and let's get back inside. Step 3. Slicing and starch removal. The potatoes climb a conveyor and drop into centrifugal drum slicers. Inside, centrifugal force flings each potato outward against razor-sharp blades mounted at the perimeter. In a fraction of a second, each potato becomes 35 uniform slices at exactly 0.06 inches thick. That thickness is not arbitrary. Too thick, and the chip fries flat and heavy. Too thin, and it folds over on itself. The factory is chasing a precise saddle-shaped curve. That gentle arch you see in a Lay's classic chip is not an accident. It is the geometric sweet spot between too flat and too curled. Different blades produce different products. Straight blades for classic, serrated blades for wavy and ruffles. After slicing, the chips drop into a fast-moving water flume that carries them to the rinse station. Multiple washing cycles strip away surface starch. Soak, high-pressure spray, second bath, another spray. Leftover starch causes chips to stick together during frying, creates oil foaming, and produces uneven browning. But the rinse also serves a hidden purpose. Reducing surface sugars in starch helps control Maillard browning, which is directly linked to acrylamide formation. Acrylamide is a chemical compound formed when starchy foods are heated above 120 degrees Celsius. In 2017, the European Union adopted binding regulation that mandated mitigation measures and benchmark levels for acrylamide in potato crisps. That regulation changed fryer set points and raw slice chemistry standards across the global industry. Your Lay's chips are shaped by a European food safety law you have never heard of. Step 4. Continuous frying. The de-starched slices plunge into a continuous immersion fryer over 40 feet long. The oil temperature hovers between 75 and 190 degrees Celsius. The chips fry for roughly 3 minutes. As moisture inside the potato evaporates into steam, oil replaces it. The fryer must be constantly replenished, but Lay's does not pour in fresh oil. They maintain a 50-50 blend of new oil and used oil. If the oil is all fresh, the chips absorb too much and become greasy. If it is all used, the chips darken too fast and develop off flavors. That ratio is a trade secret, and it is adjusted in real time based on the starch readings taken at intake. Everything on the post-fry line vibrates. Conveyors, chutes, transfer points. Every surface gently shakes. This is deliberate. Lay's classic chips are so thin and fragile that a standard rotating belt would shatter them into crumbs. The entire downstream system is designed to move delicate objects without breaking them. Think of it as a production line made of trampolines, medalles. Step 5. De-oiling, seasoning, and optical sorting. The chips exit the fryer, drain on vibratory conveyors, and pass through seasoning drums. Natural spice blends and salt are funneled through an internal dispensing tube inside a rotating tumbler. As the drum spins, the seasoning coats both sides evenly. Because the chips are still hot, the powder adheres on contact. Then comes the optical sorter. This machine scans over 400 chips per second. It looks for brown spots, burnt edges, and surface defects. When it identifies a reject, it fires a pinpoint jet of compressed air accurate to the millimeter, blowing the defective chip out of the product stream and into a reject bin. But here is the thing about that green chip. PepsiCo places a small number of intentionally colored marker chips into the fryer. These green chips are extra blistered and visually distinct. Their purpose is to measure how fast the oil and paddle system is moving product through the fryer. Workers can track the green chip's journey from one end to the other and calculate transit time. If the green chip moves too fast, the oil temperature or conveyor speed needs adjustment. If it moves too slow, chips are over-frying. It is a low-tech quality control tool inside a high-tech factory, and it is not on the label. Step 6. Weighing and bagging with nitrogen flush. The seasoned chips travel up a bucket elevator to multi-head combination weighers. Digital bucket scales calculate the optimal combination of chips to hit the exact target weight for each bag. Whether it is a 1-ounce snack size or a 13-ounce party pack, every portion is precise down to the chip. Then the chips descend into the bagging machine. After filling, the machine flushes the bag with nitrogen gas, displacing the oxygen to near 0%. This is the moment everyone talks about. The bag is not half full of air. It is full of nitrogen. That gas serves two critical functions. First, oxygen causes the oil in the chips to oxidize and turn rancid. Nitrogen is inert. It preserves freshness and extends shelf life. Second, the nitrogen cushion protects the fragile chips from being crushed during shipping. Without it, you would open a bag of powder. The bags are heat-sealed, boxed by robotic arms with carbon fiber grippers, palletized by automated guided vehicles, and loaded onto trucks for distribution. Walker's Lexter uses Schubert TLM robotic cells with lightweight carbon fiber arms specifically chosen to reduce inertia and increase packing speed. The packaging system alone is a multi-million-dollar robotics installation. Labad? Now, the question you have been waiting for: how much does it actually cost? The three cheapest commodities on Earth are oil, potato, and salt. A standard bag of Lay's costs under 50 cents to produce. It sells for between $4 and $7, depending on the store and the size. PepsiCo's snack division operates on gross margins that would make most industries weep. You are not paying for potatoes. You are paying for the branding, the distribution network Herman Lay built in the 1930s, the nitrogen flush system, the robotic packaging cells, the machine learning peeler, and 200 flavor formulations developed by food scientists. The potato is almost an afterthought. One more thing, if you eat Pringles, you are not eating potato chips. Pringles are made from dehydrated potato flakes, corn and rice flour pressed into a dough, stamped into shape, and fried. They contain so little actual potato that in the United States, the FDA ruled that Pringles cannot legally call themselves potato chips. They are labeled potato crisps instead. The iconic stackable shape is a hyperbolic paraboloid, a geometric form chosen because it resists breaking when stacked and allows efficient airflow during frying. It is engineering, not cooking. The bag you hold is a compressed industrial story, a farm in Florida that harvested the potato, a cold storage cellar holding 40 million potatoes at 45 degrees, a centrifugal slicer that turned one spud into 35 identical wafers in a tenth of a second, a fryer running a secret 50-50 oil blend calibrated by a starch test from the intake line, a green tracking chip that measured the fryer speed, a nitrogen flush that replaced every molecule of oxygen, a robotic arm made of carbon fiber that placed the bag into a box, and a profit margin that turns 50 cents into $5. That is how Lays are really made. If you're still watching, you've realized this isn't just a video about Lays. It's a breakdown of a massive industrial system. We've got a lot more to uncover, so hit subscribe and make sure you're here for the next one.